Okay, now what we're going to do is we're going to look at how to use the first and second derivative to come up with a possible graph for f. So all we're given here is f prime of x. So before we move on to our second derivative, let's first work with this one. So we talked about finding critical points. Critical points we said are points where the derivative is 0 or where the derivative is undefined. Well, this is never undefined, so we're just going to find where it's equal to 0. So let's take out a GCF of 4x squared. We're left with x minus 3. From there, we get critical points of 0 and 3. So let's put them on a sign diagram. Okay, since we're doing more than one, let's make sure we label it. So we have 0 and 3 for our x values. The derivative is 0 for each of those. Let's get our signs. So hit pause, go ahead and try to get your signs, and then hit play to check. Okay, hopefully you agree with negative, negative, positive. Keep in mind this 4x squared term is always positive, so you really just had to plug into this x minus 3 factor. This tells us that our function f is going to be decreasing, then it's going to still be decreasing, and then it's going to be increasing. Okay, so we know that here at 3 we're going to have a local min, and at 0 we don't see a change in sign, so it's not going to be a min or a max. It's going to be something else. More on that in a little bit. Let's go to our second derivative. So our second derivative, again, is pretty easy to find, just the derivative of the derivative. So 12x squared minus 24x. Again, we're going to do the same thing. We're going to set it equal to 0 and solve. We can take out a 12x. We're left with x minus 2. And when we set each of these equal to 0 and solve, we get 0 and 2. So these are possible inflection points. So just like before, let's make a sign diagram, but this time for the second derivative. So we put 0 and 2 on there. We know the second derivative is 0 at those 2 points. Just like before, hit pause, go ahead and try to find your signs, and then hit play. Okay, so that's what you get for your signs, hopefully. And again, this is referring to concavity. So what you might want to do here for the second derivative is repeat each of these so it looks like eyes, so that underneath you can do this. Remember I showed you this last time? Alright, so that's talking about where it's bent up or down. Alright, so our concavity is given to us based on those signs. Well, we have a change in concavity, so that means at x equals 0 and at x equals 2, we have an inflection point. Now, let's talk about this x equals 0 point for a moment. Do you see how it showed up back up here in the first derivative sign diagram? Well, if x equals 0 showed up here as a point where the first derivative is equal to 0, what that means is we actually have a horizontal inflection point. Okay? That is because if the first derivative is 0, then it must be horizontal at that point, right? So this value of 0, so x equals 0 is a horizontal inflection point, okay? Yes, it's an inflection point, but we can further classify it as a horizontal inflection point. So a horizontal inflection point is always going to show up on both sign diagrams. Okay, if that's the case, you know it's a horizontal inflection point. Call it a HIP if you want. All right, so now what we're going to do is try to put these pieces together and form a graph for our function f. So this is not something that you can do in one continuous motion. What you want to do is break this down. You want to identify some key points and then piece this together one part at a time. Don't try to draw this continuous function all at once. Okay? So we know that we have, let's start back up here, we know we have a local min at 3. So I'm just going to mark off here at 3, we're going to have a local min. Now, we don't know exactly what the y value is. All right, this is just a possible graph for this function. So I'm just going to pick a random spot to put my local min. Okay, now back over here at 2, all right, we know we have to have a change in concavity. We have an inflection point. And at 0, we need to have another inflection point, but this time a horizontal one. All right, so here's how we do it. So let's first look at to the left of 0. Okay, so let's look at this region up here and this region right here. Okay, so x value is less than 0. We know that we have to draw something that is decreasing and concave up. Okay, and when we hit the 0, or when we hit x equals 0, it needs to level out and have a tangent line slope that is 0. So something like that is leveling out here, okay, at 0. So it's decreasing and it's concave up, okay, in that region. And we can put an arrow on the end there. Okay, so now let's focus in on between 0 and 2. All right, and 2 up here, we could say is about there. All right, we know from up above, from 0 to 2, it's going to have to be decreasing. And looking down below here, we know it has to be bent downward or concave down. All right, so we need to draw something here that is decreasing and concave down. And by the time we hit 2, we know the concavity is going to change. Okay, so we're going to draw something that's decreasing and bent downward. Okay, so again, we don't know exactly what the y value is going to be, but I'm going to kind of darken this point here, all right, to show that that is really where my inflection point is. Back over here at x equals 0, I'm going to label this a hip for a horizontal inflection point. And again, you can see why it's horizontal, right? Tangent line slope is 0. All right, so let's keep going. The next interval is between 2 and 3. Well, between 2 and 3 up here, we know that it has to still be decreasing. And between 2 and 3 here is in this region where it's now concave up. So it has to be decreasing still, but now the concavity has to change to be concave up. So, and we know that when we get to this point down here, this is going to be a min. All right, so here is our local min point, which also ends up being an absolute min. And then beyond that point here at 3, we know that if we look back up here, so again, you're constantly looking back and forth at each of these sign diagrams. So we know that beyond x equals 3, we have to draw something that is increasing and concave up. So increasing and concave up would look something like that. So it's important that you mark off your key features, right? Your hip, your flexion point, your min. All right, it's as far as when we're grading this goes, we're looking for the x values of those points. Again, we don't know the precise y values. That's why it's just a possible sketch of f. Okay, that's all I have to say on that. Goodbye.